Hi everybody. Okay, that's working perfectly. Awesome. So thank you, Doug, for the introduction and for the keynote. Following that, we would like to give a quick introduction to what SDL is from a technical point of view. We're going to have a couple of more presentations that go more into in-depth SDL in the afternoon. So we're going to start with this. My name is Timur Pulathaneli. I'm the supervisor for AppLink partner development in North America. We do have distributed teams around the globe in Europe, in North America, South America, and in China. And I head up the North American team that works with the North American app partners. I'm located just down the road here in our Palo Alto Research Center. We have around 180 people in our Palo Alto Research Center, and we do autonomous vehicle research, but also connected vehicle research out there, and plenty of other stuff, really exciting items in our Palo Alto Center. So I'm going to give you a quick introduction to why SDL in the first place, and I think Doug made a very good case, and I just want to second that with a couple of stats that are actually 2 years old now, so it's grown even more, and you guys know, and I want to thank you for being here on the same day where's the Apple keynote, which usually everybody tries to follow. So these stats come from the Apple keynote in 2015, the WWDC one, and they had 1.5 million apps in the App Store back then. I probably have to put a new number up there tomorrow, but you're going to have 1.5 million in total. 100 billion apps have been downloaded, and that is 2015. Again, the scale just grows in this. 850 apps are downloaded every second, and you have 119 apps on an average iPhone user's phone. Let me take this off. Okay. So you see that people's life really lives in their smartphone. Everything you do is in your smartphone. It could be your favorite playlists, your favorite music, your contacts, your favorite restaurants, your favorite coffee shops you like to go to. Everything is in your smartphone. You don't really leave your smartphone at home anymore. If you leave your smartphone at home, you turn around, you go back, and you grab it. So the way to connect people to their digital life, to get people to be connected while they're driving in a safe way, is really through their smartphone and connecting all these apps that are on the smartphone to the car. So we want to do this, and we want to do this since a long time, and this says Smart Device Link, and I'm super happy that we have the Smart Device Link Consortium, but the whole story is also that we've been working with this for a long time. Internally at Ford, it used to be called AppLink at Ford, and the Smart Device Link is the open source variant, and we're really trying to get something that looks like this into the car. So if you can see this, you probably recognize it. It's a UI of Spotify on the phone. Now, why can't you use that while driving? Why is that a bad idea to use it while driving? This UI is really nice to look at on the phone. It's really nice and dark. It has a lot of buttons out there. You have like shuffle and repeat and the cover art, but it's really small. It's really hard to use while driving without taking your hands off the steering wheel and eyes off the road, which you should never do. So we really have to get to a point where we can transform this kind of user interface to a user interface that is usable while driving. And maybe not only usable while driving in an 8-inch touchscreen system, but also for somebody who doesn't have a high-end car and maybe has a more low-end 4-inch non-touch system. So you can imagine something like this transformed to our 8-inch. And this is the Sync 3 system as it's currently on the market. And if you look at the UI elements, you can find a lot of the same UI elements that you have on the smartphone application, but in a more concise way, in a clearer way to be used while driving. Additionally, the integration into the car allows the app companies to use the voice recognition system of the car and use the text-to-speech engine. So Spotify doesn't have their own voice recognition or text-to-speech engine, but through the smart device technology, they can leverage what the OEM has in their head unit and make the usage of their app much safer in the car. So high-end 8-inch system, but what about these kind of systems that are not as nice from the UI point of view, but more basic in the car, smaller, no touch screen. You use them maybe with a 5-way controller or a rotary push knob or something like that. So the way we do it with the Smart Device Link, with the template-based approach, we're not limited to the 8-inch touchscreen. So you have the same functionality that you have on the left side, in the middle, you have on the right side. So you can go and hit play, pause, save the current track you're listening to. You can go into the menu and select a different playlist if you want to. So we really work on these kind of transformations from a UI that is great to use on a phone to a UI that is great to use in a car while driving. Now the right side, even though it doesn't have this 8-inch touchscreen, it does have voice recognition and text-to-speech. So the primary control functionality that we want our drivers to use as any OEM really in the world is still there on the small touchscreen. And these kind of transformations are only possible because we use a template-based approach. So there's a lot of discussions around what do you do? Do you project the video from the app to the screen, or do you use templates? And when you do the video projection, you have to be very clear that you put a lot of burden onto the app developer. Doing video projection always means that the app developer has to create an automotive-grade UI. And all the OEMs in the room can probably attest to the difficulties you have to create a driverless direction compliant UI, something that follows the NHTSA guidelines. And I'm not sure if anybody in the room has ever read the NHTSA guidelines, but if you want to fall asleep, it's a great read on the bedside. You can have a look at them. They're really important, don't get me wrong, but it's also like with any guideline that you have that is like 200 pages long, it's a quite complicated document. So we as an OEM, we have whole teams working on the human-machine interface, the HMI in the car. And these teams basically do nothing other than creating a UI and then making sure that UI is actually driver distraction friendly. If you imagine to put that work on each app developer, it is just a waste of time. Plus, all the UI people at app companies are really focused on like the design element. They have no constraints on the phone. They never think about something like button size and hitability on a phone, on a car UI. So when you think about putting it all on the app developer, you really create a lot of burden on them. Now, when you go talk to them and ask them how they want to get into the car, they will always tell you they want to have a full streaming, they want to have the UI in the car, and they want to put everything in there. But when you sit down and you explain to them what NHTSA is and what these guidelines are, all of a sudden they find these template-based solutions really interesting and started to see the benefit of getting into the car fast. One of the items that our hackathon shows yesterday and today again is that with the template-based approach, you're quick. You're quick to market, you're quick into the car. You can use the templates, and of course, it's a little bit of a difference to what your UI looks on the phone, but it blends in really nicely with the rest of the infotainment system. So your app is a good citizen on the infotainment system in the car and can still provide all the features that you want your users to have. So usually we sit down with app developers and they come around to the idea of using templates and really like to use the templates. Plus, all these templates get more powerful as we speak. So we're talking about the SDL and the evolution of Smart Device Link. And not only do we work on the code quality and improvements and new access to vehicle data items, but we're also working on improving the templates and trying to make more templates available, better templates available to the app developers. So when we talk about Smart Device Link, there are three main functionalities for Smart Device Link. You can really imagine it as an extended user interface for the phone through the templates. So as I spoke before, you can get access to voice recognition. And you can get access to the center stack buttons and actually also to the steering wheel controls. This is another big advantage of using a template-based approach where you are in control of the communication. When you use a video streaming approach, usually what you do is you stream the video from the phone and you give back the touch events to the app. When you do a template-based approach, you can do stuff like subscribe to specific buttons. So when you subscribe to the skip button in an SDL-enabled vehicle, you actually be able to get the events that come out from the steering wheel. So if the customer presses the steering wheel skip button, your app will be notified that this button was pressed. The same notification that you would get when they press the skip soft button on the screen, or if they don't have a touch screen, the soft button, the hard button that is in the center console. So with the template-based approach, you can get access to a lot of different controls, and you could imagine having something like a rear seat entertainment system that actually also relays information to the app. The other thing is, and I jump ahead here, so the other thing is the output. So you want to be able to give information to your users. And to do that, you can use the screen. You can, of course, display information. You can do the text-to-speech, and you can use the text-to-speech engine in the car. And that is something that I want to reiterate that's really, really powerful. Especially when we started SDL, there were not a lot of VR or TTS engines around in apps themselves. So the text-to-speech engine in the car allows app developers to communicate with the user in a way that's least distracting while driving. So I always like to bring up one of our app partners as an example. And in Europe, we have a sport app that is basically a soccer app. Everybody loves soccer in Europe. So you have this app on your phone, you have your favorite team set up, and whenever there's a game of your favorite team, you get a push notification, so your phone vibrates. Now, because everybody's soccer crazy, everybody needs to know right away what the new score is of their favorite team. But obviously, as soon as your phone buzzes, you shouldn't reach in and pull it out and check the score and maybe have to unlock your phone and interact with the phone while driving. So what this app does is basically connected via Bluetooth through the smart devicing technologies. It just sits there. It doesn't really do anything in the car. You just sit there, you're still connected. But as soon as that notification comes in, it uses the text-to-speech engine in the car to let you know what happened during that game. So you can imagine we can reduce that distraction from a phone buzzing and either you're curious what happened or you're actually reaching in and checking your notifications to having a seamless experience where you're driving and then you get a voice prompt from your car letting you know what happened. So the text-to-speech functionality is really, really powerful. And that is paired with the notifications from the background. So something that you don't have to actively engage with, but it just sits there and waits until it's needed and gives you notifications that are not only location-based, but also give you information about things that are happening in a time space. And then the third part, which app developers are always really interested in, and Doug touched on it as well from an OEM perspective, is vehicle data. So smart devicing offers a fixed set of vehicle data items, and app developers can get access to it. But it's very important to know that for smart devicing, the users, the drivers, are really the ones that own their data. So they have to decide ultimately if they want to give their data to an app. So how this works is kind of a two-tiered approach. So app developers, if they come to us and say we want to get access to, for example, the GPS position of the car, they're going to have a compelling use case that they show up with, and they get the approval from Ford for this use case for the GPS data. Now, if they have the GPS access from Ford, we have our backend systems where we can put this in and record it. Now, you come into the car and you're a user, you downloaded that app, you connect it to the car, and when you start it in the car, what you're going to get is a little pop-up. It's a notification that informs you that the app wants to get access to your GPS position. Now, you as a user have the opportunity to opt out of this at any time. So you can say yes or no to that pop-up. But even if you say yes to the pop-up, you can still go into the settings menu and disable it afterwards. So it's very similar to how iOS, for example, handles their data sharing. What we want to make sure is that the customer really owns the data. They don't give it out without their knowledge. They don't give it out without their consent. Smart devicing is built around these kind of safety measures so that data is protected. And I talked about the use case of our sport partner. We have a lot of different applications. Now, what comes to mind, of course, is music. And we have a lot of music partners. We have a couple of them in the room. And we show Spotify here, but iHeartRadio, of course, is one of our great music partners as well as Pandora and SiriusXM Mobile. So we have a lot of different music partners. And we have audiobook partners. So if you think about what people really like to access while they're driving, and you think about the more traditional infotainment spaces, it's their music, which nowadays it's all streamed from their phone. So we got to have an alternative to bring that in. And Audiotheca is one of our audiobook partners, so you get access to your audiobooks, but also information. So in Europe, one of our partners, Die Welt, which is a newspaper in Germany. So what they actually did was they had every night they recorded the 10 most important news of the day from broadcasters, so radio broadcasters. They recorded that, so when you had your morning commute, you didn't have to wait for the top of the hour to get your news. You could actually start the app and it would read out the most important news of the day. And then if you're not interested in sports or you're not interested in politics, you could skip to a category you're really interested in right away. So this is kind of the news broadcasting 2.0, where you don't actually have to listen through the whole broadcast. That's maybe not interesting for you, but you can skip and you can dynamically access content, which is only possible through an integration like Smart Device Link that gets you direct control of the app. We also have voice services. So of course, voice service is a big deal nowadays with Alexa out there as one of our partners. We announced them at CES 2017. We showed the app that is going to launch later this year for the Ford vehicles. And one of the nice things that SDL has is access to the audio in the car. So when you are an app, you can actually request the audio input from the microphone. So what happens with Alexa is, and all the other audio services that integrate with Smart Device Link, they request access to the audio service in the car. And as in that sense, whatever you're speaking to the microphone in the car will be piped through to the app itself in a binary audio format. And then the app can send that to the backend servers and respond. So you can bypass the voice recognition system in the car and use the voice directly in your app and then send it out to your backend service and respond. And this gives a whole range of features to the customer because voice services are very broad. And if you look at the Alexa service, you have tons of skills that you can activate. You can play Jeopardy while you're driving via voice. You can listen to your music. You can listen to your audiobooks. You can ask for the weather and ask for news. And it's basically just everything all around. Plus, the integration with Smart Device Link even improves these voice services. So with the Alexa integration, for example, when you go and ask for a coffee shop nearby, it will show you the coffee shops in your vicinity based on the GPS position from the car. So with your voice service, traditionally, you're locked into the zip code that you put into the settings app, and that's what kind of response it gives to you. But in the car situation, of course, your position is way more dynamic. So the Alexa app uses the GPS position from the car, and based on that, gives you coffee shops nearby. Now, because of the SDL integration, it can show these coffee shops on the screen. The user can select one of them, and as soon as they select one of these places, this location gets sent to the embedded navigation system of the car automatically. And these kind of integrations that make it seamless to switch between the voice service, that is the Alexa voice service, and the embedded navigation system in the car make Smart Device Link special and make it really, really usable and driver distraction friendly for the driver. The other kind of category is location-based services, and I touched upon for the Alexa service with the location and points of interest. Glimpse is another example of one of our partner apps where Glimpse sends your position to somebody. So let's say you're on your way home, you're in a traffic jam, you want to inform your wife that you're late. So you can go into Glimpse and use voice recognition to send your location to your favorite contacts without actually taking your phone out or using your phone at all. And these are examples that we're doing, and we just came out of a hackathon yesterday. We have hackathons around the world with all our global teams. The picture here is from our Tel Aviv hackathon, maybe the most beautiful one given the location on the beach. But I have to say our location yesterday wasn't bad either, I think, with a view of San Francisco. And we go out and try to communicate with developers, can try to invite them to join us to dream up new use cases. In the car space is really something that we are very keen on getting new use cases in and new experiences for our customers, because everybody knows music, everybody knows audiobooks, but we have a lot of things that are possible. And in the ceremony later today in the developer conference, you're going to see some of these innovative use cases that came out of the hackathon yesterday and this morning. So we invite everybody to come in with innovative use cases, and I'm sure the coolest apps that are out there we haven't seen yet, and they will come in the next couple of years. So a lot of different options to work with and a lot of different kind of use cases, but there are some restrictions to Smart Device Link. As I said before, the idea of Smart Device Link is really to reduce the driver distraction and not increase it. So what Hands-Free Profile kind of did for the phone call, where you don't have to take your phone out and use it in your hand while driving, that is what we try to do for your Spotify app and for your apps on the phone. So these restrictions are needed to actually ensure driver distraction. So, big lock, so you know it's an important restriction. No video. So we don't want you to watch a YouTube video while you're driving. Still eyes on the road, hands on the steering wheel. So these are apps that we usually don't approve. These are not use cases we want to have in the car. Second one would be long text. So I told you guys about the Welt news application in Germany, and this read out the news. So it would not make sense to have a newspaper that shows you the news written on your screen. Again, eyes on the road, hands on the steering wheel. We don't want people to actually look at the screen for a long time. So whenever you have an application, these applications should give out that information in a precise and short form. And that's why we don't allow long text to be shown while driving. And then no gaming. Especially no visual gaming. So we don't want you to do like a Mario type of jump and run game on your screen while you're driving, right? So there's no gaming while you're driving. And these driver distraction guidelines, because of the template-based approach, we have a big benefit of being able to enforce them differently in different regions. So, for example, Russia has a very different driver distraction mindset than North America has. So we have some functionalities in Smart Device Link that are actually disabled while driving in North America, but enabled in Russia or in Europe. So through these templates, we can dynamically adapt these driver distraction restrictions toward the market without the app developer even having to change anything in their app. So you don't have to sit down and get like the list of 200 countries out and understand the driver distraction rules in every country. You can just use the templates, use Smart Device Link, and you know you're going to be compatible to all driver distraction laws in all the different markets. So this is a big plus as well for app developers. Now, developers. Most importantly for this ecosystem, right? We need people to participate from all our stakeholders. So we have the people that actually use the app. We have the OEMs, which a lot of them are in the room today, and bring their technology into the head unit. But we also want to have app developers creating apps for Smart Device Link. So to do that, they need the resources. And similar to the way developer.apple.com works, we have smartdevicelink.com, and we also have developer.ford.com for all the Ford-specific stuff. On the website, you're going to find our software libraries. Front and foremost, of course, you need a software library to implement Smart Device Link into your application. So the software library is available on iOS and on Android. We don't have any libraries for Xamarin, C#, as I was asked yesterday. No JavaScript integrations at the moment. It's really for the native applications. And for iOS, you can use them with Swift or with Objective-C. Depends on your liking. The Android library is, of course, a native Java library. And you can download them from there or from our GitHub. We do have reference guides, and we have getting started guides. When you get started and you develop a Smart Device Link app, there are a lot of things that you don't know, because Smart Device Link is really technology people in the app world don't usually work with. It is something unusual to connect to a car. So we made sure that on smartdevicelink.com, we have all the guides you need to get you started and to get the app developer started, and have the getting started guides that guide you through an implementation of Smart Device Link from your native app that doesn't have any connection to the car to a fully fledged Smart Device Link integration with all the different features, be it the send location feature I just mentioned earlier, where you can hand over a location to the embedded navigation system, or something like dial number, where you can actually initiate a phone call on the head unit from your application. But we also have reference guides, and in the second part of today, we're going to actually go through these pieces for the developer a little bit closer, and going to have a look at how the Smart Device Link Consortium actually tackles all these problems. Because on here, these are just bullet points. Technical hardware documentation, these are just bullet points. It looks really easy, but if you actually sit down and create these documents, you have to have a good process to go through and create these, keeping them updated, keeping them correct, and also keeping them nice looking on your website. So that's not that easy. So I'm going to talk about that a little bit later today. We also have simulators online. We do have a couple of simulators now, actually. So there is the Ford simulator that simulates a Ford Sync 3 system. It's very similar to the 8-inch system we've seen on the screen earlier. Very concise. It has all the features that the Sync system has, and you can control it from your application and connect to it, and you can get all the different vehicle data items that we have in our specification in Smart Device Link. But then earlier this year, we also launched a new simulator that is called Manticore, which is a project of the SDL Consortium. Manticore basically allows you to connect to an SDL instance, like it looks like a head unit. It's a simulated head unit basically, but this is hosted on the web. So you don't have to download anything. You don't have to create a virtual machine and run something on Ubuntu. You can just go on the website and start up an instance and then connect to that instance on the web with your application via TCP/IP. No installation needed whatsoever. We're going to also talk about this a little bit later today and kind of give you an insight about how this works. And then you get additional resources, because when you develop the app, it's also important to think about best practices. Think about how should the app actually be implemented, what is the best practice to interact with the driver, what is the best practice to use voice recognition, what are the assets you can use in your app if you want to use any assets. And then on developer.ford.com, we also have the Ford acceptance criteria. Smart Device Link tries to align all the different acceptance criteria. So there's going to be a certification process for Smart Device Link that gives you like a baseline certification. But one of the things that the open source nature of the Smart Device Link project really allows OEMs to do is certify apps themselves. So they can go in, and if an app was certified by the Smart Device Link Consortium, the OEMs can decide themselves if they want to have these apps accepted or not. And some OEMs may have a higher quality level or have a partnership with a specific app partner that is exclusive and cannot bring another app partner on. And other OEMs will take on every app partner that was certified by the Smart Device Link Consortium. But this is something we're going to see in the future. And for Ford's acceptance criteria, you can go to developer.ford.com and check that out there. We have more resources nowadays. You can see select.smartdevicelink.com. So if you want to hang out with us, or if you want to ask us questions, really anything around Smart Device Link, the right people to ask are all in that Slack channel. So we have a couple of stats for that, because I think it's really cool. We have 911 registered users that access that. And at this point of the screenshot, 67 users were online at the same time, which is a pretty cool number for an open source project that is roughly half a year old now. We have 81,000 messages that were sent. So there's a lot of discussions going on, a lot of questions being asked. The Ford team, the Livio team, the Toyota team, all the different participants and stakeholders in the Smart Device Link Consortium are in that Slack channel and answer questions basically around the clock. Given the global nature of our project, there's really no sleeping on the Smart Device Link Slack channel, so there's always something going on. You can ask any question. So if you have a technical question, if you have a business question, if you have a head unit question, if you have an app question, the thing with this Slack is, even if you don't know the answer, we're going to find somebody who knows the answer for you guys. So don't hesitate to come in and participate in that discussion around there. And then I talked a lot about templates, and I just want to quickly put a stake in the ground here for video navigation and video projection. So for all the normal apps we have, everything that is music, news, information, we want to use templates. Templates really make it easy, as I said before, for the developer to get into the car, for a developer to be compliant to a driver distraction, and for a developer to be usable while driving in a safe way. The one thing where templates don't really work is navigation. We cannot have a navigation template that allows navigation apps to somehow manipulate a static view in the car. So we do have video projection for mobile navigation apps. You can see an example up there. And the idea here is the same as with other solutions. We want to be able to allow the driver to use their navigation application on the big 8-inch screen in the car. Of course, this kind of solution won't be available on a 4-inch non-touch system that doesn't have graphics support. But on the bigger screens, like this 8-inch screen, or maybe on 10-inch screens, 13-inch screens, who knows where this growth will lead us, it's really helpful to get the navigation application from your small smartphone screen up to on the big screen in the car. Plus, your navigation experience can be improved by, for example, using the GPS position in the car, because the GPS position in the car is not the same as the GPS position on your phone. As you know, GPS position on your phone is based on a GPS signal that the phone receives and then calculates the position. The car also receives that GPS position. The big difference is if you don't have reception, if you don't get any GPS signal, the car can still determine its position based on the spinning of the wheels, steering wheel angle, and actually can adjust for the missing signal from the GPS. But the phone cannot really do that. So you get a way more accurate GPS position, and this really helps you when you navigate through tunnel systems or in cities that have very high buildings like New York City downtown. It helps you to have a more precise location in the city. So this is something where we actually allow video projection from the phone. There are guidelines around that for driver distraction, but when you work with mobile navigation partners, they all have a drive mode because that is what their app is set up for. That is why they have this app. So they don't have big problems with driver distraction. It is more the apps that never worked in a car before that have problems with driver distraction, and therefore that's the one we're helping with the templates. And then working together with all our stakeholders, we have everything open. So Smart Device Link is a real open source project. We don't hide anything. So if you go to github.com/smartdevicelink, you're going to find tons of repositories in there. And we have repositories for our iOS library, for the Android library, for the core software. So when you have a Ford vehicle in front of you and you see the infotainment system, the code that's running on the infotainment system is the same one as you're going to find on this repository. Which is pretty interesting. OEMs usually don't like to share their data. So all the OEMs that are participating in Smart Device Link, they use that code that is on the SDL core repository. But you also have repositories for other things. We have a lot of tools that we're going to talk about later today that help developers and also OEMs. All these tools are also available free to use on the open source GitHub repositories. And so you can just go there and download them. Plus, we use GitHub for a lot of our processes. So when you look at the evolution process, the way we actually improve the smart device ecosystem, that one is also based on GitHub, and we use that to write down proposals and to discuss proposals. So if you're interested what's coming up in the pipeline of Smart Device Link, all of that is open on the GitHub page. The SDL Consortium, and I think we talked quite a bit about this, the SDL Consortium itself has a couple of leading members, which are really the ones that drive it on a diamond and platinum level. And we work together since we announced the SDL Consortium in January. We have a great growth in membership and tremendous interest in the industry on this. And so we organized in a couple of different levels. So when you look at the organization of the Smart Device Link Consortium, you have the board, which basically governs the overall affairs of SDLC. So it's the highest entity we have in the Smart Device Link Consortium, and it answers all the important questions. But for a day-to-day operations level, we do have a different committee. So we call it the steering committee, and this is really the technical heart of Smart Device Link. This committee decides everything on a technical level, and for the high strategic questions, it goes up to the board and asks for direction, and for the low-level, working-level technical items, the steering committee comes together and discusses them. Plus, we have a developer relations committee, which is really our voice to the outside. So the developer relations committee is the one that organizes events like this. So we come together and the SDL community comes together where app developers, OEMs, and users meet and discuss Smart Device Link. It also interacts with the developers, makes sure the website is fine, and potential members for the SDLC consortium. Now, the steering committee is the technical committee of the Smart Device Link Consortium. It was started as well in January 2017 when we created the Smart Device Link Consortium, and we meet every week, and we have 94 proposals that are created, and Doug showed the stats for accepted proposals, but 94 proposals were created. So independent of if they were rejected or accepted or are still in the review process, it's an impressive number of improvements to Smart Device Link, which will benefit all the members that are participating in this. So we discuss roughly 4 proposals a week. And so 4 proposals a week is a good number because these proposals are quite in-depth. These are changes to our libraries, changes to our APIs, improvements to our core system on the head unit. So we have to discuss them in depth to understand what the changes are, how it will impact the different stakeholders in the ecosystem, and then discuss if we want to accept them, if we want to reject them, or if we want to change them. So it's an option to go back and defer a proposal, come back a week later with changes, and then accept these changes. And as I said, we meet weekly and we have global attendance. So creating something like the Smart Devices Consortium is not something that's only done in the US. The Smart Devices Consortium is actually global, which does make it hard for some people. So for me, living on the West Coast, this is the one time in my life I think I have the best meeting time for this meeting. So it's like 3 p.m. Tuesdays. It's going to come up later today, and it's really relaxed nicely in my work day. Our East Coast colleagues have it at 8 p.m. have it at 6 p.m. So not that great. But if you work in Japan or you work in Europe, you have either 7 a.m. or a midnight time for this meeting. So it's not great, but it's really tough to bring everybody together around the globe. So we're making these kind of compromises to get everybody together and work on this and keep everybody informed that is in the Smart Devices Consortium. And you can see that, as I said, we're pretty open. So you can find all of this on github.com/smartdevicing/SDL_evolution. And in there, you're going to find all the proposals, 94 proposals, as I said. And I did count them this morning, so I do know you can go in there and you can read all of them if you're interested. You can go into the discussions and you can actually comment on them. So if you think something is not well done, something is not well designed, you can go in there and put your 2 cents in and comment on the issues. And you can see which ones are in review currently, which we're currently discussing, which ones are approved, and all the information that you need around the SDL evolution process. The nice thing about this is this also helps us to keep track of things. So all these evolution items, when they get accepted, they automatically go through a process where they create work tasks for the consortium to create the code that is needed for this evolution item to be implemented. So when you go and look at an evolution item and you look at one that is already implemented, you can actually click through, you can click into the issue, you see a link to the work item that was created in the issue, you go into that work item, you can see the code commits that were actually done to implement this item. So from the evolution process, from the idea of this proposal, to all the way to the end, to the actual implementation in the source code, you have traceability, which helps us tremendously to work with these proposals and see their impact on the code. Now, we have 3 big stakeholders, and I just want to reiterate kind of like what smart devising is and what it's based on and who is really part of smart devising. So we do have the customers, and their real goal is to stay connected. They don't really care how they stay connected. They don't really care what technology to use. What they want is to use Spotify. What they want is to use their news application. What they want is to message their friends while driving. So to make that safe, they don't really care what technology they use. They just want to stay connected. And what they also want is control over their data. So they don't really want to lose their data or their control over the data. So these are 2 items that's one of our main stakeholders, the users, because without the users, we don't need to create Smart Device Link. If nobody's going to use these apps, it doesn't make any sense. The second stakeholder we have are the OEMs, the automotive companies, and the tier 1s in this. So we want to deliver innovation quickly to the driver. And as everybody who works in the automotive industry knows, this is probably one of the slowest industries in the world. It's really hard to get something out of the door. It's really hard to get something into a car. It takes a long time to develop stuff. And even though we, as a lot of other OEMs, improve in this and we improve our life cycles and we make it quicker to get stuff into the car, we will never be able to get to a rate that the mobile app industry has. We will never be able to create a product out of the nothing in 2 months and bring it to market in 2 months. So what we do with the smart devising technology is we allow somebody to create an app, to create a use case, to create a business, and deliver that to the car, to the OEMs in a matter of months instead of in a matter of years. So for the OEM, for us, it's really important to be able to do these kind of things, to make our customers happy, to keep them connected. And we have controlled access to the car. As Doug was referring to earlier, it is really nice to have a direct relationship to app developers, to be able to work with them directly on data access, on usage of information from the customer, and get this direct relationship without a third party being involved in that. The third stakeholder in this is the app developer. Because Smart Device Link Consortium, we don't pay app developers. So what they want is they want to have a high volume platform to go to. Because if we don't have a lot of users, there's no need for an app developer to actually develop an app for this platform. So with Smart Device Link, we ensure that we have a high volume platform and we have an open source solution to allow them to trust this solution. The one big problem that app developers have, they don't trust automotive companies, which I can understand. We do change our course from time to time. There are a lot of systems that get stood up by different OEMs, and then if it's only one OEM, they shut it down again and use another technology. With Smart Device Link and with the number of people involved in this, we give the app developers trust into the solution. They know that if they invest today into Smart Device Link, they're going to not regret it tomorrow, but they can build on these investments and get to more and more people as more and more cars and manufacturers join the Smart Device Link Consortium. So especially in the situation where you don't pay app developers, you got to have a platform they trust. You got to have a platform they rely on, and you got to have a platform they bet on in the future. We do have a lot of competition with CarPlay and Android Auto. I always tell people, CarPlay and Android Auto is a different solution to the same problem. It is how do people stay connected. So the Smart Device Link Consortium, we have to be the best solution to this problem, and we have to be better and offer features that maybe other platforms cannot offer. And we have to gain the trust of the app developers. And this Smart Device Link Consortium really helps us with this kind of problem, bringing the trust back into the automotive manufacturers and getting app developers on board to really invest their resources. Because we don't pay them, but they have to decide, do we implement feature A, do we implement feature B, do we use CarPlay, do we use Android Auto, do we use Smart Device Link? And the only way to really get them to use Smart Device Link is these kind of high volume platforms and the trust that they give us. So this is the closing remark on this. I just want to give one more note on the later talks. So you've seen a couple of topics that we just slightly touched on in this presentation. This afternoon, we're going to have an ecosystem presentation where we're going to go through a lot of the tools and kind of explain what the ecosystem really is to give you an idea of how big Smart Device Link really is. So when you look at this presentation, it looks like just one of these like connected solutions, and there's not really much behind it. But when we go through the presentation this afternoon, you're going to see all the software we have created, all the processes we have created, and the foundation that we created to really build for the future of the Smart Device Link Consortium. Now, this was a lot of talking for me. If you guys have any questions, I'm happy to take them, and we can discuss a little bit and see what you guys think.
I have a microphone.
Okay, there's a microphone.
And a booming voice. And I need to see some shows of patties because Timur gets paid by the answer. Well, there's a question.
Otherwise, I would have to make up answers without questions.
Hi. I'm wondering when Smart Device Link will have access to the tuner to be able to control that.
Absolutely. So the tuner access is on our roadmap. It's actually going to be released, and Joey, correct me if I'm wrong, with the 4.4 release of all core software for the head units. Now, the way that Smart Device Link works is, of course, you have the release of the core software that the Smart Device Link Consortium releases, and then the different OEMs pick that release up and integrate that into their car. So when we release Smart Device Link 4.4 for the core later this year, then we're probably going to have an integration maybe next year, maybe the year after. We're going to see that every OEM decides on their own when they're going to release this functionality. And usually OEMs like to announce these type of things in press release and don't like me to blur that out. So we're going to see when that comes out. But it's not far off. And if you're interested in how this will be done, you can actually go to smartdevicelink.com already and to our GitHub repositories and have a look at how this will be done in the future.
I know you touched on this already, but I wondered if you could talk a little bit more about the process that developers would go through in submitting their apps, having them approved, having them distributed for commercial use, just to give us a sense of timing and some of the steps and level of complexity and the like.
Oh, absolutely, yes. So I think one thing that I didn't make really clear is the way we like apps to be distributed. I didn't touch on that earlier, so I'd like to come back. Very good question. So we want to make it easy. Most importantly, we want to make it easy. So we want to make it easy for our customers. So there's no for SDL apps. So there's no Spotify for SDL or Spotify or iHeartRadio for SDL. What we really want to do is have app developers integrate the smart device link library into their main app. So when we talk about distribution, if you guys have Spotify on your phone, you already have an SDL enabled app on your phone. There's nothing else to do. So when we talk about discoverability and being able to find SDL apps, you don't have to search for them specifically. You don't have to sit down and try to understand what is an SDL app and what is not. Our idea is that you have the apps that you like on your phone already, and when you get in the car, they just pop up in the car. No other discoverability needed. So when you talk about distribution, this is kind of how we want to distribute apps. So there's no special app store or anything like that. The OEMs do help with discoverability with specific websites or apps or even in-car solutions. But the real idea is with the SDL Consortium, we have so many apps in our portfolio that if you have your favorite app, that is enabled in the car. And that's kind of the long-term goal, but that's kind of the distribution idea. When we talk about certification and getting an app through the process to be actually available for smart device in cars, the tools we're going to discuss in the second part today, and we're going to look a little bit at our website and at the things that you can already do on smartdevicelink.com. But if you want to have a high-level idea of how this works is, you go and basically enable your app first. So you get the library online, you go through the guides, you get help from the Smart Device Link Slack, and then you integrate that into your app. After that, there is going to be a baseline certification that's going to be available from the Smart Device Link Consortium that you have to go through kind of yourself. Kind of understand, am I compliant or not to what the certification is doing. And then we work with the Smart Device Link Consortium. One of the big tasks in the Developer Relations Committee currently is kind of defining these criteria with what you have to be done. But then you basically submit your app to the Smart Device Link Consortium. There's going to be a certification process in Smart Device Link that is across all OEMs. So you get a base certification for SDL. And then the OEMs can decide to pick you up. Now if you work with OEMs, there are some things that differentiate OEMs from each other. Some of them are premium OEMs, so if you buy a $150,000 car, you may only want to have very high-end apps that maybe only these OEMs only allow very specific apps that meet very high criteria, or an app has an exclusive, or an OEM has an exclusive relationship to an app and may not be able to accept any other apps in that category on their system. But in generally, the idea is if you have the baseline certification, you're an SDL-enabled app, every OEM can get that information from our central SDL servers and then allow these apps to be used in the car and to be discovered. And so these APIs are going to talk in the second part today. I'm going to show you kind of these APIs and how the centralized server works and how it looks for an app developer to create their ID and to get more information on smartdevicelink.com. Cool. Any other questions? Anything else you want to bring up?
So it sounds like SDL is open source, but you allow OEMs to choose the versions and maybe able to customize on top of it, right? So what's your advice for developers who build apps and who can bring very consistent customer or user experience across different OEMs? So for example, some cars may have this features like video streaming, but someone may not have it. Someone may have very different audio inputs structure, and someone may have very different ones. And then, for app developers, we have to build cases for different, compatible OEMs, right? And what's your advice there? Thanks.
Oh yeah, absolutely. So very good question regarding different capabilities in different cars. So the SDL platform was created to be an access portal to a lot of different types of cars. Maybe some have graphic support, some others don't have graphic support. An app will get all that information when it connects and can decide if they want to support this head unit or not. What we would like, because as an SDL consortium, we would like the user to stay connected independent of he can see a graphic on the screen or not. So what we would like is that an app developer basically just doesn't use one of the features if it's not available, so then just don't upload an image or just don't use audio pass-through, for example. But if your app relies on one of these features and will not work without the feature, you will get an information from the car that this feature is not available, and you can inform the user about that and can tell him, unfortunately, because you don't support graphics, we cannot do this kind of feature for you. And we do understand that it is unfortunate to have these kind of like cars that don't support features, but given the diversity on the automotive market, it is basically impossible without limiting yourself to a very small number of head units to be able to deliver a 100% consistent experience. So what we do is more dynamic. We tell the app, these are the available options in the car. You can decide if you want to run or not. And that allows us to connect a lot of different cars with a lot of different capabilities. But of course, will restrict some apps that need a specific capability, a specific feature, to only the cars that have this feature.
All right, we have time for one more, I think. Quick answer or long answer?
I can do quick answers for two of them.
Just a follow-up question of the previous one, like the connectivity to the internet, how will you address that one? It will be also the OEM vendor dependent or something else?
The access to the internet for the apps is done through the smartphone. So one of the nice things of smart devices is it doesn't cost you anything. You don't have to buy a data plan from an OEM to use smart devices. You already pay for a data plan that you have on your phone, so you use that for music, for example, or for other items for other apps that you use in the car. So there's no additional data needed. It's all used on the phone. When you talk about access to the internet from the car, the nice thing about smart devices being an open source solution is other OEMs can also put up proprietary solutions on top of that. So if there's something that is like a concept of one OEM and they want to put it on top of Smart Device Link, they're free to do that on top of SDL. We of course like everything to be contributed back, everything that helps the community. But if you want to have some kind of proprietary internet connection from your head unit through the user's phone to the web or through a companion app, you can as well use that. I think we have one more question we can do real quick. I have 2 minutes.
Is it a quick one, Roger? I don't know, you don't ever ask short questions.
Very quick. So you have projected navigation for Europe and China, US?
So the SDL Consortium supports projected navigation. It's like the first statement. The second one, Ford launched that version this year, and we launched it for the global markets for iOS, and currently the Android version is available in China, which we're gonna roll out globally in the future. So yes, for the US as well, with iOS at the moment.